Hello dear authors and invited guests, and welcome to technical session 5A. I'm just going to quickly share my screen here, so hopefully everyone can see that. It is my good morning, good afternoon, and good evening wherever you are, and it is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems, Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. And also, we wish everyone and their families a protected time, and we all together pass this soon. We hope you enjoy 2 days of the knowledgeable and interactive sessions. Just before we get started, I would like to introduce you to the chair for this session. So that is Dalia Magdi from Egypt. Just a bit about Dalia. So she is an associate professor at CIC Canadian International College. She was head of information systems department in the French University in Egypt, co-director of the CRI research lab, associate professor of management information systems. So thank you for chairing this session. Now I'd like to start with the papers. Also, there is a special note for the presenters. You'll be given 12 minutes for the presentations. On 10 minutes, I'll raise a gentle reminder request. While the presentation is going on, other participants kindly be muted. So I'm just going to stop sharing my screen. I'm sorry. So we're just going to move to our first presenter of the day. So that is Oja Bajracharya from the Asian Institute of Technology in Thailand, and his paper is an Internet of Things system for laundry monitoring service. So whenever you are ready.
Yes, thank you. I'll start sharing my screen now. I hope you can see my screen.
Yes, we can see your screen.
Okay, so greetings to everyone. I'd first like to thank the conference organizers for giving us this opportunity to present our work. I'm Oza Bajracharya, and I'll be presenting our paper, An Internet of Things System for a Laundry Monitoring Service, on behalf of our team in Thailand. So washing dirty laundry is a chore that all of us are familiar with. In a place such as a university campus, hotels, or hospitals where there are shared laundry rooms, it is a hassle to find out if a washing machine is available. It would be really convenient to know the availability of the machines beforehand. There are products already available in the market which deliver this feature, but they are most of the time not really cost effective. So our intention was to mitigate this problem by developing a scalable, easy to install, cost effective system, which would allow the users to know the status of the washing machines beforehand. We have proposed a LMS device made from just the ESP32 microcontroller and MPU9250 accelerometer, which are inexpensive and readily available in the market. The LMS device that we have proposed is developed in an open source platform and will give the availability of the washing machines based on the vibrations of the machine during its various cycles. So during our literature survey while developing this LMS device, we found out that the abundance of the research that was done focused primarily on the vibration patterns during the operation of the washing machine and on reducing this vibration to enhance the longevity of the washing machines. So our goal from the get-go was to design and develop an economical solution for getting the real-time status of a washing machine. The idea of the initial investigation was first studying the vibration of the data we would obtain for one full cycle of operation of the washing machine. The picture on the left shows a data logger which was made using a Raspberry Pi B, which was interfaced with a MPU9250 unit using the I2C protocol. All the tests were performed on a vertical axis Samsung washing machine with a clothing load of 6.6 kilograms. The sampling frequency taken was 500 Hertz. Logging results for two placements were recorded, one for the top lid placement of the washing machine and one for the side of the chassis. As you can see, here are two plots obtained from the logging data. The top plot is for the side placement of the data logger and the bottom plot is for the top placement of the data logger. For fair comparison, the axial orientation of the accelerometer was kept the same for both the placements of the data logger. By looking at the data and comparing it with the normal operation of the washing machine, we could deduce that the machine went through the following phases: pre-wash, wash, rinse, second wash, drain, dry spin, and then lastly sound alarm. As evident from the plots, during some of the phases of the wash cycle, the acceleration values obtained were very low. So it was important to develop an algorithm that would be able to differentiate between these idle states and the available state. Looking at the trend of the data, the idle periods do not exceed a time of more than 8 minutes, given that the washing machine is operating normally. So it was safe for us to assume a guard time of 10 minutes. And if the idle time exceeded more than the guard time, the machine was deemed available. This is our system, which comprises an end node attached to each washing machine. These end nodes are connected to a router or a access point using Wi-Fi protocol. The end node communicates with our custom backend written in Node.js and Express framework. The PostgreSQL database is responsible for storing the end node device data, device metadata, and other configuration information. The actual network architecture in case of a production environment would be the architecture as it is shown in the slide. However, for designing the prototype, Raspberry Pi itself acts as an access point, a router, and also the host for all the servers. The end nodes and the client connect with the Raspberry Pi with Wi-Fi, and they will be able to exchange the information using the MQTT protocol. The implementation of the prototype realization was done in the private network inside our college. For more details regarding the end node device, as you can see from the picture on the right, it has an accelerometer MPU 9250, a microcontroller ESP32, and a PSP port to hold all the circuitry together, and 2 status LEDs. The red LED indicates that the ESP32 has successfully established a Wi-Fi and MQTT connection with the server, and the green LED indicates that the ESP32 is verified by our platform and now can send data to the server. For this system, we opted to develop an algorithm which was based on the statistical measure of mean. The L2 norm of the acceleration along the 3-axis over a short period of time is compared to a governing threshold for determining the washing machine states. In step number 3, A bar is the aggregate mean of 10 seconds, beta is some user supplied offset value that is used for calibration purposes, and alpha is the threshold value to which we compare our resultant accelerations for determining the machine states. Firstly, the ESP32 collects the accelerometer data for 1 second and then calculates its resultant mean amplitude. For the purpose of efficient memory utilization of the microcontroller, these aggregated 1 second data were further collected for a period of 10 seconds and then averaged. Then the absolute value of the mean of 10-second accelerometer data was compared to a threshold. If the acceleration value was less than the threshold, the device was idle, else it was busy. In steps 9, it checks if the device has been in idle state for more than 10 minutes. If the device has been in the idle state for more than 10 minutes, the state of the washing machine is changed to the available state. So after deploying all the servers in the Raspberry Pi and burning the firmware codes into the ESP32 end nodes, we attached our LMS devices on the washing machines. The weight of the laundry we used was approximately 6.6 kilograms, and the end nodes were placed in the top lid and the side of the chassis of the washing machine. The first topmost plot is the desired output that we expected from our algorithm. As you can see, the machine is available initially, and then during its 60 minutes of operation, it is busy, and then it is available again. So from the bottom 2 plots, we can see that our algorithm worked indeed correctly, and then it is available in the initial state, and then busy or idle during its 60 minutes of operation, and then available again. These are our administrator UI, the client UI, and the fully encased LMS node. The leftmost picture is the administrator UI that we have developed for the LMS device. Any node that has been connected to the network will be shown as an unverified device in the UI. The administrator will first need to map this device as our own, and then it will appear in the mapped device list. This process is the step when the administrator will have to provide the offset values and the threshold values. After it appears in the map device list, it will start sending the data to the server, as you can see from the plot here. It can also be edited further to change the offset value or the threshold value if needed. And also it can be deleted or restarted from the UI itself. In the client UI, the user can see if the washing machine is available, busy, or idle. So next, I would like to show you a demonstration video of our paper. I hope you can hear the sound. So that covers just about everything I wanted to talk about the laundry monitoring service that we have developed. We are able to successfully develop a prototype which was able to distinguish the states of the washing machine based on the vibration parameters. From the results, we came to a conclusion that the placement of the LMS node didn't matter if it was top or the side. Besides distinguishing the states, it can also be deployed to assess the health of the machine by analyzing anomalies in the vibration data. Finally, it is applicable for any other electrical equipment, as washing machine is not the only device that vibrates during its operation. I hope this presentation provided some insight into our paper. Thank you for listening. If you have any questions, I'd be pleased to answer them.
Hello.
Hello, yeah.
I want to ask about the cost of this machine. Is it cost effective, or you didn't study the part of cost concerning the cost?
Yeah, actually we had estimated the cost of the machine, but I currently do not have those in my slide. I can tell you the cost if you I can tell you the cost later in email if you can reach out to me.
Okay. Thank you.
Okay, thank you so much.
Thank you, Oja, for your presentation. If anyone in the audience has any questions, please use the chat function. I'm just going to quickly share my screen. Here we are. Hopefully everyone can see that. So our next presenter is Jonathan Herrera from the Escuela Politécnica Nacional in Ecuador, and his paper title is Characterizing Phishing Attacks Using Natural Language Processing. So whenever you're ready, Jonathan.
Thank you. Good afternoon with everyone. Okay, I hope you can see my presentation. So what we did was characterizing phishing attacks using natural language processing. The content of this presentation is going to be divided in these sections: motivation and goals, methodology, results, and conclusions. And the motivation and goals. First, what is the motivation to do this kind of research? First, we need to be aware of the increasing complexity of phishing attacks. Phishing attacks are improving by reducing the number of errors and using more similar sites. Um, the phishing attacks are even using HTTPS with some trust vendors. We also need an automated process because we need a better scalability during the analysis of the data, and we need to train the people in the decision-making process in order to improve the ability for individuals so that they could better recognize the factors that correspond to a phishing attack. What are the goals of this research? We need to understand the decision-making process. That is really important because we want to create an automated process for analyzing this data, and we also need to create new mechanisms for phishing detection in order to reduce the attacks and improve the detection will help us to reduce the attacks in order by implementing automated models. So that's one of the main goals of our research. What was the methodology? Well, first, the data collection. The data was collected using a web platform. In this platform, participants were asked to differentiate phishing from legitimate emails. As we can see in the image that is being shown right now, the participants were given 10 exercises in order to differentiate between phishing emails and legitimate ones. The time taken, the mouse movement, the items that were focused by the participants, and the clicks made were also recorded. The participants were asked at the end of each exercise to emit a comment as to how they reached the conclusion um, for their assessment of the email, whether it was legitimate or it was a phishing email. Um, we also used an analysis with a neural network. And here we can see the neural network. This is the architecture that we use in the neural network. In the left side, we can see the comment part of the neural network. This side is the one that processes the comments of the phishing exercises of the participants. The rest of the neural network is processing all the automatic data that was collected. We did this in order to make a prediction um, as a prediction that helped us um, train these numerical representations. The part that we are using for the following steps is only the comment part of the neural network. This part on the left side of the architecture, because we wanted to obtain a numerical representation of each of the comments the participants uh, made. So with the numerical representation, we performed clustering analysis with the k-means technique. As we can see, here is the graphic of the elbow method that shows the average distortion of each of the clusters. In this case, with 10 clusters, we have the least change in the average distortion. That's why we choose to use 10 clusters. With this technique, we could identify groups of comments with similar responses. In this case, as I said before, we use the numerical representation in order to perform the clustering technique. We use the data obtained from this clustering technique in order to perform these decision trees. These decision trees were performed manually with the data obtained from people with full insight. People with full insight is people that has experience and background in cybersecurity. Therefore, we can trust their decision-making process, and we could perform these decision trees. The weight in the decision trees is obtained from the data that we collected from these people. Finally, we can see that the clustering results correspond to the decision tree that we obtained earlier. These results are comparable to the ones that we obtained from the groups of people with a background in cybersecurity. For example, in this case, we are seeing one of the groups, in it's group number 3, and it has comments all related. Of course, they are in Spanish, but they are all related to the discussing of the legitimacy of the emails based on the URL or links that were sent inside the email. This clustering was made, as I said, with comments from everyone, and disregarding their background. And we can see that it has a really strong correlation with the decision tree that we made earlier. Finally, we can see that we obtained some useful insights in the decision-making process. The numerical representations of the comments gave useful insights, and the decision tree also helped us understand the differences between legitimate and phishing emails. As we saw earlier, we had a really strong correlation between the clustering and the decision tree. The decision tree was made with cyber security experts, while the clustering process was made with responses from everyone. We also have a great scalability with this combined process, because we now have a model that was trained, and we can use it to obtain the numerical representation in case that we have more participants. In this case, we had 54 participants, and each had 10 exercises. So in total, we had to analyze 540 responses. That's one of the reasons that we use this method in order to obtain a greater scalability. In future research, we intend to increase the number of participants and to increase the representations of different parts of the public. Our intention is to learn the decision-making process of different persons with different backgrounds in order to help improve the phishing detection algorithms and to prevent phishing attacks in the future. We also pretend to include different analysis techniques such as attention mechanisms that we could use if we get more data in the future. Thank you. Any questions?
Thank you.
If there are any questions from the audience, or if the session shares any questions for the presenter. If not, we can move on. Yep, okay. Thank you very much,
No,
Jonathan.
thank you. Thank you.
Thank you very much, Jonathan, for your presentation. So we're just going to move on to the next presenter. So I'm just going to share my screen. So our next presenter is Michael Okopa from Makerere University in Uganda, and his paper title is Modeling Connectivity for Vehicular Ad Hoc Networks Under Interference.
I thank you so much, the host. I would like to thank you for giving me this opportunity to present our paper. The title of our paper is Modeling Connectivity for Vehicular Ad Hoc Networks Under Interference. I hope you can get me clearly.
Yes, we can hear you clearly.
Okay, thanks. VANETs, that is vehicular ad hoc networks, have been proposed to provide safety and reduce cases of accidents on the roads by enabling real-time safety and management information exchange between the vehicles in the networks. We also note that VANETs are normally dispersed. They are self-organized communication networks characterized by very high movements and restricted movement patterns. They are normally supported by the fixed or mobile infrastructure. However, due to the nature of the VANET, connectivity between the vehicles is normally very challenging. The motivation behind our research, one, given that network connectivity in VANETs have mainly been analyzed using different analytical frameworks, but with the assumption of light traffic, specifically focusing on the inter-vehicle spacing and then interference being key factors in determining the performance in terms of connectivity probability as the performance metrics. Now, under light traffic, the inter-vehicle spacing is assumed to follow the exponential is negligible. I must also mention that the connectivity probability here expresses the probability that messages can be received by the base stations, which provide possibilities for connections, or even moving vehicles under what we call the vehicle-to-vehicular infrastructure. The second motivation is that the connectivity analysis is actually very important in designing the routing protocols and network architecture in vehicular networks. So one challenge is that under high density traffic, we find that the inter-vehicle spacing no longer follows the exponential distribution. And the secondly, the interference cannot be ignored from the neighboring vehicles. Our contribution here is that we came up with a model, an analytical model, that incorporates interference and high traffic density. And then secondly, we evaluated the performance of the proposed models and evaluated it against the one without consideration of interference. Now, our system model consisted of a 2-lane bidirectional road located in a high-density traffic scenario, and the vehicles can only communicate within range. We also considered the ad hoc-based deployment scenario, where vehicles are connected without the physical links. They can be connected using wireless links. We also considered an advertising model, which is used for exchanging the safety messages, and it is under the broadcasting model. We looked at the forwarding vehicle sending this information to the neighboring vehicles which are nearest to it. We should note here that the communication is normally backwards. The front vehicles normally communicate to the backward to send safety messages, informing the subsequent vehicles about any dangers that may be ahead. Another assumption we made here is that the vehicles move at constant speed and the spacing between the vehicles are the same. Now, to determine the communication interference of other vehicles on the connectivity between two vehicles, it is normally important to describe or get the characteristics and determine the model that best describes the characteristics of that particular environment. We decided to choose the Nakagami model that has been proved to be accurate in modeling interference. That is the model we use, unlike the exponential distribution that was previously used. This model has also been confirmed in other researches as accurately modeling environments with high traffic density. We moved ahead to determine or derive the expression for the connectivity probability in terms of the fading parameter, the communication range, the length of the road vehicle density. The performance of the vehicles in terms of connectivity probability was done using MATLAB as our tool. Some of the implementation parameters that we use we got from the previous researches, like the fading parameter, the vehicular ranges that were previously considered, and also the vehicle density. So what did we find? Our performance evaluation. We varied the communication range while incorporating interference using the fading parameter, and also we considered scenarios where there's no interference, and we looked at the influence on the connectivity probability. We noted that when there is interference, the connectivity probability will be much lower because when interference is incorporated, there is interruption in the signals, and this reduces the connectivity. It is also noted that the difference is more pronounced as the communication range increases. We also looked at the variation of connectivity probability with the communication range while looking at the intensity, the different vehicle intensity. We looked at a scenario where we have 0.0036 vehicles per meter, and then another scenario where we have 0.004 vehicles per meter. We note that when interference is not incorporated, the observation is different. We find that when interference is not incorporated, increase in the vehicular density will always improve connectivity. However, this is not the same when interference is incorporated. We find that instead, the interference will lead to lowering the connectivity probability as observed from our graphs there. We also looked at the variation of connectivity probability with the length of the road. Here, we are looking at the communication range being lower than the whole segment of the road in consideration. We also note that as the length of the road increases, we find that the connectivity will be reduced. The explanation is that when the interference is incorporated, the longer the length of the road, the more vehicles that are considered, and this implies that the more the interference is caused to the communicating vehicles. We also note that as the length of the road increases, we find that there is increased difference between the situation when interference is incorporated and when interference is not considered in the models. In conclusion, we noted that increase in traffic density normally leads to decrease in connectivity when interference is considered. We also noted that the connectivity probability of the vehicles increase with increase in the communication range, because as the communication range increases, there is an increased possibility of the vehicles getting connected. We further also note that the increased interference leads to a decrease in connectivity probability, as red highlighted in number 1. And lastly, we found that the connectivity probability decreases with increase in the length of the road segment. Thank you for listening to me. Back to you.
Thank you very much, Michael. If Dalia or anyone from the audience has any questions.
No, thank you. I really like the work. Thank you.
That's perfect. So thank you very much, Michael. I think we're just going to move on to our next presenter. I'm just going to quickly.
Can I ask you a small curiosity?
Yes, right. If anyone has any question, I think so. Dr. Libero has a question. Please, sir.
I would ask you about you have some comparison of your model with other similar models. Can you have some information about the accuracy of your modeling and the results? Thank you.
Can I get your pardon again? It wasn't clear.
I just asked about if you have data, accuracy data of your modeling approach with other similar approach.
I'm sorry, I cannot get it, but
let me explain. I think he's asking about the accuracy of your model as compared to other models.
Okay. As I said, we decided to use the parameters that were also previously used in other models. But our performance, what we observed or what we noted, is not very different from what was previously done in other research work. However, it was done using simulations, which are normally a bit slow when you consider simulations. We decided to come up with an analytical model that is much faster to produce the results. Thank you.
Thank you.
That's perfect. Thank you very much, Michael. And we're just going to move on to our next presenter. So our next presenter is Mario y Nina Quispe Soto from Universidad Privada del Norte in Peru. And his paper title is called Technology and Crime Prevention, a Systematic Review of Literature.
Good morning to everyone. Okay,
Good morning.
I'm going to share the presentation. Can you see the presentation, please?
Yes, we can see the presentation.
Okay, thank you. Well, good morning to everyone again. My name is Mario Nina Quispe Soto. I'm from Peru, from the University Privada del Norte here in Peru. The paper I'm going to present is titled Technology and Crime Prevention, a Systematic Review of Literature. Well, talking about the crime and prevention technology, in recent years, and even more since the COVID-19 pandemic, social networks, the cloud, Internet of Things, artificial intelligence, and many other technology tools occupy a privileged place in the world. Thus, it not can be denied that evolution of technology has benefit social development. However, it has also favored criminal environment. Crime and prevention technology, among the technological tools for crime prevention, there are predictive programs that we are first used in France in 1994, but their development since the year 2000 extends to Europe, starting with Sweden, Italy, and United Kingdom, Belgium, and Netherlands, Germany, Spain, Denmark, and Austria. The first software was Anacrime, followed by I2 Analyze Notebook, Key Crime, Predpol, and others. There were 20 software programs in 2018. These technological tools allow the analysis of a large amount of information and uncertain as the occurrence of a criminal act. Well, a serious social problem. The Inter-American Development Bank found that between 2004 and 2014, the majority of countries experienced annual growth rates close to 4%. Poverty rates declined, and Latin American and Caribbean citizens became healthier and more educated. However, it also found that crime increased behind the Latin American and Caribbean region, the most violent in the world. So Peru, as an integral country of the southern continent, is obviously also affected by the aforementioned increase in crime, but also as in other parts of the world, technology is not unknown to it. So it should be asked, what technological tools are being applied as crime prevention tools over the past 10 years? That's the problem of our paper. The objective in this study is to carry out a systematic analysis of literature on technological tools applied to prevention of crime during the last 10 years. We applied the methodology applied with a systematic review of literature based on a PRISMA approved preferred reporting of items for systematic review and meta-analysis, which is based on the verification of a list of 27 criteria and the use of a four phases papers related to the subject of study. We start reviewing a 1987 publication founding that using the research words using databases like ProQuest, Scopus, Cielo, Redalic, EBSCO, Then we discard 1911 articles by the title doesn't not correspond to the problem addressed, or the publication is not related to the objective of this research. Then 153 potential articles for their evaluation regarding the selection criteria for the study. So we discard 76 articles for being outside the study selection criteria, like year, language, crime prevention, etc. And then we had 77 potential articles for our full review, for content and relevance. And finally, we worked with 41 relevant articles for the development of this research. Talking about the results, we worked with a total to 41 articles. 21 of them from DialNet databases, that represents 51% of the total the articles. Then 10 articles were from Scopus, that represents the 24%. 6 from ProQuest, that represent 15%, and finally Redalic 3 and Alicia Concitec databases from Peru, one article that represent the 2%. In this table, in table 2, we can see that technological tools the technological tools applied by the authors of the 41 articles we reviewed. And in this case, the most popular or the most used technological tool was artificial intelligence, with 19 articles applied for prevention crime. That represents 24%. The main technological tools applied in these 41 studies are shown in this table too. Appreciating that the publication period was from 2013 to 2021, being almost 30% of 2019. The studies have greater relevance in the application of artificial intelligence, 24%, and information technology, 23%. And the least evidence use robotics, satellite, and data mining. Another subject in the use of operational research tools, where it is evident the use of neuronal networks to simulate the behavior on the human mind. In table 3, we can see The technological tool supplies in crime prevention per author. Um, which shows that artificial intelligence and especially the application of big data, data mining, and machine learning are addressing with their files of application, where their use in crime prevention is evident. Likewise, many authors have applied more than one of these technological tools to address different processes associated with the crime prevention and investigation, as this once allowed the analysis of many variables, such as the identification of criminal patterns, dates, time, place, trends, physical features, and alleged perpetrators, systematization of information, among others. Can say about the crime addressed application. Here we describe the context in which technological has been used as a means technological to prevent crime in general, such as civil, commercial, and criminal offense, specifically offense between individuals which do not necessarily require offense include offense containing function inextricable linked to the function of guardianship of legal assent and have a penalty as a sanction. In turn, four authors investigate the application of technology to prevent the crime of robbery especially, which is understandable because robbery is a universalized crime as well as plural offenses, since it occurs with violence and intimidation. It was also found that other authors investigate of the application of technology to prevent sexual violence, prevent homicide, and homicide in the form of parricide, to prevent homicide plus theft and robbery, to prevent sales of narcotics, the crime of terrorism and cybercrime. The application of technology can be made from various approved. It was found that two authors investigate the application of technological tools from the governmental sector, which involves a study within the faculty filed jurisdiction and authority to make one things belong to all the people, to view of criminal processing and analyze the application of technological tools from the proof of the criminal. In other words, the study is comprehensive in the sense that criminology deals with criminal behavior and how societies respond to it. In addition, it studies crime of the penal system. Finally, some authors analyze the application of technology from the disciplines of criminal, which definitely makes good use of technology. While its function is not investigation but establishing the motive, evidence, circumstance, as well as the means used for the execution and the identification of perpetrator and perpetrators. While the articles identify analyze the application of technology for crime prevention according to the purpose for which they were selected, these articles also address the purpose of crime prevention thought technological, like improve public health pointed out that this legal right and recently being infringed by organized crime, the security of house search with the proper protection of fundamental right, a situation demands in a country where there is a protected approach to criminal law. In this table, in table 4, we can see the impact criteria of the technological tools used in crime prevention. Summarize the findings of this impact, it could be assumed that application of digital tools is a natural tedious problem, such as the prevention and resolution of criminal processing will be beneficial. However, it is that several authors, among them some indicates that the use of this technological could harm in some way the judicial impartiality to be exercised in any criminal processing, as well as have a negative impact of the due process to be followed, since it is a matter of emulating human behavior, analysis and system that can be considered by the judge or jury for artificial behavior, such an algorithm, code, or robot. And the positive impact represented by the use of digital tools of the recognition of crime perpetrator is reflected in the geo-referencing of acts, prediction of crime, place, dates, scenarios, among other, and this based on multiple recorded information of events that occurred seriously. The application of big data, data mining, and machine learning represent very powerful tools to discover previously unknown patterns and trends, in addition to helping the detection of patterns and trends by the machine learning, supervised or unsupervised from input data. A clear positive strain is 76 of the reviews in the computation of data of criminal processing, which means greater control and precision of those relevant details that will be allowed for proper decision making in the judicial area. These decisions are especially objective, limiting sub-objectives or generalities about process that include information such as date, number of perpetrator, place, etc. And the conclusion of these papers, we can say that uh, we can say that among the main technological tools used and means of crime prevention, certain process of big data for the efficient management of large volumes of data stand out, artificial intelligence to replicate the characteristic social behavior of the criminal decision making after finding patterns and summarizing large volumes of data in a comprehensive and useful way. Machine learning, which are aimed at machine learning as they incorporate up-to-date data. These tools become then a great opportunity to prevent, confront, and investigate the commission of crimes, which include large scenes, data, and perpetrator. However, it should be considered that the use of technology must be in conformity with fundamental rights, while criminal police is limited by the provisions of the political constitution of Peru. Over the past 10 years, eight technological tools for crime prevention have been applied. The most common are artificial intelligence and information technology with 47%, data mining, machine learning, and big data with 29%, operational research, satellites, and robotics with 24%. Crimes that face the greatest application of technological tools are criminal offenses in general, with an incidence of 25%, fraud, environmental and robbery crimes with an incidence of 28, that 56%, and other with 46%. there is then a task for the people involvement, the continuous innovation and extrapolation of technology to contribute to the reduce of crime. Thank you so much. Is there any question?
Thank you, Mario. If the audience or if the session chair has any questions for the presenter.
Yes, please. I want to ask about the technology. Does the technology differ according to the application? For example, in governmental sector, do we prefer to use some technologies more than others or something like that? Did you study something like that?
Well, most of the authors that we review it apply the artificial intelligence because it's the powerful of this technology is too big, no? But ultimately we are applied operational research with neural networks because is one of the most technology with more application because the complexity here in Peru.
Yeah.
Yeah.
Okay. Yeah, I got it. Thank you.
Okay, thank you so much.
Thank you very much for your presentation and your answer to that question, Mario. So I'm just going to move on to our next presenter. So I'm just going to share my screen. So our next presenter is Yunus Ed Degumi, and he's from University of Sultan Moulay Slimani in Morocco, and his paper title is Detection System Potholes on Roads Based on Recurrent Neuronal Networks.
Hello everyone, can you hear me?
Yeah.
Okay, I shared my presentation. Can you see my presentation?
Not at the moment. We can't. No. Now we can see. Yes.
Yes. Okay. Thank you. No, thank you for this opportunity to present this work. My name is Yunus. I am PhD in the Faculty of Science of Beni Mellal in Morocco. I present this article entitled Detection System Pothole in road-based and recurrent neuronal network. For the abstract, the supervision of road quality is one of the research axes in road safety. The object of our work is to propose an efficient and accurate system to provide a complete and detailed report in the state of the road and to anticipate the maintenance to release by exploiting the various techniques of deep learning. Our approach is to limit the analysis area of road based on a deep learning architecture of two models in two steps. A segmentation model to limit the detection area of road and a detection model of pothole or fissure. For introduction, the detection of damage and cracked parts of the infrastructure depended only on the expertise of the engineering team for experimentation. The analysis report of the engineering team use more time and financial resource. It is very long for analysis our road for country or city. For motivation, for this reason, the development an automatic road analysis system seems as an alternative to accelerate the road inspection process and provide an analysis report in a short time. The challenge is work described hybrid approach to pothole detection based on two deep learning architecture. the convolution neural networks and the convolution encoder decoder for the segmentation, the area route. For related work, various methods have been proposed to detect pothole in a road. The classicals with pothole detection based on super vector machines, SVM, use the Kinect sensor to detect a pothole for the profounder and detect the fissure is dangerous or not. Detect crack with a convolutional neural network using a stereo vision system, and the last work using deep learning neural network to detect potholes. Our approach, proposed architecture used in different times because we need to execute two models in one work. It's not good for real time, but you can use it in different time. The combination of segmentation and detection of pothole in a road. First architecture, the CNN architecture, donc you detect the pothole, you have an image of pothole and you use different layer for convolution and max pooling for connection layer and classification with the pothole or no potholes. And the next models, you use the segmentation model, like the convolution encoder decoder. Like you have an image with normal, and with this model, we can segmentation and selected area route for a more analysis. No, this is a global view of the analysis of an image, such that the image is passed at the same time to the two models segmentation and detection separately. And after the appearance, donc you have for detect pothole, you can detect two potholes, but two potholes is positive detection, but one is false positive detection. But the one model he can't decide it is the false positive. And we have next model, he select the area, okay, segmentation the route, no, select the area route, and after fusion this result, we can select it just the only two positive detection. No, we can eliminate the pothole, but is not significant pothole for analysis. And for our system, workflow analysis with intersection over onion for the sequence video, sequence frame. For tracking to reduce duplication pothole. You have first get frame and detection potholes, and tracking these potholes. If no matched with the existing object of pothole, he save result. But he matched an existing pothole with the EOE, I not save it and repeat with the next frame. For experiment, I used the dataset public dataset image captured by a GoPro to this camera with a high resolution. That is a public dataset. We can is good labelization and access for other projects. And the experimented, the training of dataset is split into two steps. First step is the training on the segmentation of the route, and the second step is the training to detect of potholes. Our result, I use the model of segmentation, dans APT, United ResetNet, Unit VGG, and I use the last models for detection, efficient net. But you have YOLO T or other models. I have more details in my work. Look, I have accuracy 93% of the result for test. Okay, I think it's a good result. Look, for conclusion, in this work, I will present pothole detection by combining two deep learning architecture, segmentation and detection. Our solution is executed in delayed time for this. In our next work, we try to upgrade our system to real-time detection with segmentation. Donc, the next work, I try to use it one models for executed in real time. Thank you for your attention, and if you have any question. Thank you.
Thank you very much, Eunice. If anyone from the audience or the session chair has any questions.
No, thank you.
No worries. Thank you very much for your presentation, Eunice. So we're just going to move on to our next presenter. So I'm just going to share my screen again. So our next presenter is Libero Negro from University of Calabria in Italy, and his paper title is Performance Prediction of Scalable Multi-Agent Systems Using Parallel Theatre. So whenever you are ready.
Okay, thank you for presentation. And I try to share my video. I will give some big feedback that the slides are visible. Are my slides visible?
Yes, sorry, it's
okay.
visible, yes.
Thank you. I will start my presentation by telling you that we have the goal, the research goal to develop, implement an approach, a software engineering approach for studying complex multi-agent systems which are challenging. And our goal is both modeling, but also performance prediction using a simulation as analysis technique. Now, our approach is based on actor, and we use our theater actor system, which we developed in Java. However, the approach in reality consists of two basic steps. The first step is that of using a formal approach, in the sense that the approach based on actor, we use it in the Opal toolbox using timed automata, which allow us to design the model of the mass of the multi-agent system and to check its correctness. This is a fundamental aspect from the software engineering point of view. The second step of our approach is to port the software, the model, to port it in Java using the implementation of Theatre in Java, and then executing the model both on a standalone machine, on a single core, or on a multi-core machine where we can exploit some speed up when executing very large models. Now, in my presentation, I give you some idea of the approach by applying applying the theater to a significant case study, which is the studying minority game. I think many of you knows about minority game, which is often used in the economic world, but not only in economic world, for predicting the behavior of inductive players. Now, just a few words about theater, parallel theater in particular. As you see, theater is based on a parallel architecture in which we split the application in multiple theatres. Each theatre in its internal consists of, obviously, a set of actors which express the application. It also has the control layer, where we do the work of controlling a message, scheduling and dispatching. And also there is a transport layer for receiving from other theatres messages or actors which are moved on this theatre. Now, theatre. what is interesting to recall is that actor use only asynchronous message passing as the communication mechanism. They share no data. So we studied our theater implementation in such a way to have two levels of concurrency. We have a cooperative concurrency within a single theater, and we have a parallel execution among distinct theatres, which can be mapped on distinct cores of a multi-core, many-core machine. And what is important to stress is that our architecture is a totally lock-free architecture, in the sense that we do not use lock in any case, neither in the application actors, but also we don't use lock in the runtime system implementation. Okay, the modeler can choose the number of theatres of a given application, also considering the parallel degree of the machine, the use of the machine, how many cores, physical cores we have at our disposal. Okay, now a few words about the minority game and what we have done with it. Minority game is a well-known binary game based on inductive reasoning, in the sense that agents learn from the experience. They do not exchange information, do not interact each other, but from the evolution of the game, agents learn how to adapt their behavior. And in this model, we have a population of players which are competing in the use of a scarce resource, limited resource. And they must compete in the use of this scarce limited resource, I repeat, without interactions, explicit interactions. Now, the idea of the minority game in reality was abstracted by Charles Zhang in 1977, starting from the Brian Arthur problem, well known, which is the Diel-Farol bar problem. And the Diel-Farol bar problem synthetically expresses the minority game purpose. We have n players which at each weekend have to independently decide to go, if to go to the bar or stay at home. Decision, binary decision, A or B, 1 or 0, 1 or -1, etc. By knowing that space at the bar is scarce. And therefore, if a great number of visiting players would choose to go to the bar, there will be congestion and so no comfort. So the best behavior for players is to be part of the minority side. This is the name of the game. Now, minority game has another interpretation in the trade market economic field, where, for example, players have the possibility to exploit a new business opportunity. Obviously, if many people would choose to take a business opportunity, the gain for each of them would be low. So the few are the players who engage the business opportunity the best is the result. Now, some formal definition of the minority game. Practically N, which is the population size, is an odd number, and it is the number of the players which engage in the minority game for a large number of steps, T, and at each step, each player has to decide, has to choose A or B. When all the players have chosen, have decided about the choice, the outcome is determined, and then the outcome will be broadcast to players, which can then adapt the behavior for the next step. What is important is that the player will know the minority side, but not its numerosity. This is an information not known to players. Now, in which way then the player make some adaptation, and so in which way they behave? In reality, each player is equipped of a memory M, which store last outcomes of the game, few last outcomes. For example, in this table, the memory consists of 3 bits, and so we remember the last 3 outcomes of the game. In addition, each player is equipped also of a local pool of strategy indicated by S. And as you see, a strategy is a binary function, and the strategy suggests to the player on the basis of the memory content what should be the next decision of the player. The space omega of all the possible strategy is obviously this number, 2 raised to 2 raised to m. Initially, each player initializes randomly the bits of the memory and also the bits of each strategy in the local pool of the player. What is interesting is that after each step of the minority game, each player knows the outcome, then it receives a real score, a real point, if the agent was able to predict the outcome. But the agent, the player, also has the possibility from knowing the outcome of this step to give a reward or a blame to each strategy in its local pool, depending on the fact if such a strategy would have been used, it would have been predicted correctly the outcome. And at each new step of the game, the player decision will be based on the highest rewarded local strategy. Now, to give an idea in which way evolves the minority game, normally all the model try to illustrate the attendance trend. What is the attendance? The attendance is just the numerosity of a given side. The user, the model, can choose indifferently A or B, and so at each step, it is important to see what are the fluctuation of the attendance around the middle point. In particular, the middle point given by n-1 divided 2, because I repeat, the number n is an odd number. So this value is the highest possible numerosity of a winning side. Now, just to recall some important result concerning minority game, it has been already verified that as the intelligence of player increases, in other terms, we increase the number of bits in the M store, the fluctuation of the attendance, as one can expect, reduce. In the sense that the more is the past history which the player has at its disposal, the more is the past history, better is from the point of view of the decision. And also, there is another well-known behavior for a given brain size, a number of bits of memory. In general, it has been observed it is not good to increase the number of local strategies, because as the number of local strategy increases, in a sense, the player tend to be confounded. The more are the strategy, the more is confused the player. And one can see this aspect by, for example, observing that increasing the number of local strategy it diminishes the frequency of success of each, on the average, of each player. Now, another well-known fact of a minority game is that when players do their job in minority game, in reality, each player, through blaming and rewarding strategy, in reality, players learn how to choose strategies. And what it emerges from a practical experiment is that in a classical minority game, a good performer player continues to be a good performer, in a sense that definitely each player understands what kind of player or what kind of strategy to use. But what is bad is that a bad performer, unfortunately, continues to be a bad performer. So in the literature, there was a proposal among the various variations of the minority game. CCHO proposed a genetic variation of the minority game, in the sense that after a given time in which a player detects it is a bad performer, it has the possibility to choose two other strategies in its local pool of strategy and to apply a crossover point on this mother strategy. We can see that each strategy is obviously a vector of bits. Choosing crossover, we can make a mutation so that from two mother strategies, we can achieve two child strategies. This opportunity can be exploited in different ways, in the sense that we can have a different way of choosing the mother strategy to crossover and mutate, and also the child strategies can be differently used to replace other two strategies. For example, in this case, I would only mention, for example, the strategy by which mother strategy, for example, are randomly chosen in the local pool of strategy, and after crossover mutation, child strategies replace the two worst performance strategy. And also I would mention that the policy by which mother strategy, please listen carefully, mother strategy are chosen among the best performing strategy, and after genetic algorithm, child strategy replaces the two worst performance strategy. Intuitively, the policy D should be very good, because we take two mother strategy among the best strategy and try to achieve two by mutation, crossover mutation, two child strategy which replace two worst performing strategies. Now, the benefit of using such kind of genetic algorithm can be illustrated by not only through the use of the attendance, but also through the use, for example, of this scaled utility function, which is which create a value in 0-1 interval, and the most close to 1 is the value of the scaled utility function. Best is the coordination among players. Now, I have not much time to describe in detail what we have done, but I give you an idea. First of all, we designed the model of a minority game, but also of the generic variant, using actors modeled in UPA. And we use the manager, which is the orchestra director, which asks a player to do decision, collects the replay, evaluates the outcome, and then broadcasts again to each player the outcome. The manager, obviously we have a player, we have also a main actor, which is responsible of initialization. And what we have observed. In UPAL, we check the correctness of the model by observing, for example, the attendance when, for example, we used a memory brain size for and 4 strategies. And you see, in this case, with the limited brain size, bits of memory, there are some oscillation, there are some fluctuation around the middle point. We used in UPAL 101 player and 1,000 steps. As you see on the right, when we increase the bits of the memory, you see that the fluctuation are very short around the middle point. The 2 pictures in the lower part of the slide respectively show what is the frequency of success when we use memory size of 4, number of strategy 4, and when we use always memory size 4, but 12 strategy. As you can see, definitely the success frequency in this case goes to about 41%. But when we increase the number of strategy, the frequency of success lowers at about 36%. You see that the frequency of success reduces. Now, also in UPAL, we studied the genetic variation of a minority game, and you see the effect, for example, of policy D. Policy D, when we choose 2 mother strategy among the best performing strategy, and replace the 2 worst performing strategy. In this case, in a sense, players understand how to behave in the best way. And you see also from the fluctuation which tends to reduce definitely, but also the scaled utility function which definitely tends to 1. So best coordination. The next step of our work was to port the model in Java using the theater architecture we have. And this is just giving you a flavor of the programming style in Java, in a sense that a player becomes a normal class which extends the actor as a class, and messages are tagged as a message server. And as you see in this case, we have three message. Also, we achieved the 2 versions of the program. One to be executed on a standalone machine, and one for parallel execution. And
sorry,
I give you just
sorry, Libero, you have you've got 2 minutes left for your presentation.
I go immediately to conclusion because I know there is not much time to express the work one has done. Thank you. And I will tell you that we achieved a similar result to UPAL, but what is important, by increasing the population size and by using more steps. Also, we, for example, compare the policy B with the policy D. As you see, also when we increase the population size, we achieve performance prediction of the genetic version of minority game. As a last point in my presentation, I would tell you that we studied a scaled version of the model, in the sense that we used a very large population, and in reality we built 2 versions of the parallel program. One which is timed, in the sense that we use explicit 1 time step at each variation of a step. And when we use the timed version, you see that we have a speed up of about 2 less greater than 2 when we use 35,001 players. Obviously, we used a multi-core machine with the quad-core machine with 4 cores. Okay, but since there is no need to use explicit time, because use of time means there is a need to synchronize the various theatre at each time unit. So there is a heavy cost of time synchronization. We realized also an untimed version. And in this case, we achieved a speed up greater than 2 also when we used 10,001 players. I repeat that all the property, all the performance curves were confirmed by all the population sizes. Okay, we are trying in this moment to improve the implementation of theatre, and also we try to exploit data parallelism so as to exploit the L2 cache of cores. And also, we planned also to apply our approach to other variants which are defined in the literature. But theatre is also used in our research also to approaching the real-time cyber physical system, modeling, analysis, and also implementation of cyber physical system using again the same actor system, theatre. Okay, I have finished. Thank you for your attention. If you have any question, I'm here. Thank you again.
Thank you very much, Libero. If anyone from the audience or Dalia has any questions for Libero.
No, thank you.
No, that's perfect. So thank you very much, Libero, for your presentation.
Okay.
So I'm just gonna quickly. I want to sincerely thank all the authors for their excellent presentation contribution in this session, and all the participants for being part of this international conference. This session is very informative. All the presenters will be getting their digital certificates through the email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of WS4 2021. I would also like to thank our session chair, Dr. Dalia Magdi, for chairing this session. So I'm just going to quickly share the screen so you can see that. So this is a token of our appreciation to the chair on behalf of Team WS4 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence. I'd like to kindly request everyone turns on their camera for a quick snapshot of the virtual conference.
Yes, thank you, Dalia. Dr. Dalia, do you want to share something with presenters?
And no, I want to thank all the researchers who participated in the conference. Their work was really valuable and interesting. Thank you.
Yeah, thank you, Dr. Dalia. So we request everyone to please turn on their camera just for the quick memory. Yes. Okay, thank you, everyone. And now, if anyone has any question, with presenter, or if you want to talk with each other, I will keep open this session for some time. You can put the question into the chat box, or if you want to share your email addresses, for the future communication or something. So I will keep this session on for more 5 minutes.
Okay.
Thank you, Dr. Dalia.
Thank you.
Bye.
Bye.
Thank you.
Take care. Take care.